In this video, we are going to configure DNS, and we are going to turn my Raspberry Pi into a DNS server using the bind package. When we talk about DNS servers, we have three types of configuration to choose from. The first option is the caching-only DNS server. The second option is the forward-only DNS server. And the third one is the authoritative server, which provides us information about different zones. This third option is the most complicated from the three of them. So we are not going to build an authoritative DNS server in this video. I might create a video of DNS zones and records in the future, but now we are going to focus on the first two types of options, the caching and the forwarding configuration, which are pretty straightforward. We only have to remember a few keywords. Let's start with the installation of the required packages. First, I am going to update my repositories. And install the bind package, which is called bind 9 on Debian-based distros. If you have a Red Hat-based system, this package is just called bind without the 9. I have already installed it, as you can see. So once we have successfully installed the bind package, let's enter the etc bind directory where the configuration files are located. The main configuration file is called named.conf, but we are not going to edit this file. As you can see, there are several files included here, and the one we are interested in the most is the one with the dot options at the end. So let's open this file. At first, we are going to configure the caching only server, and we don't have to modify a lot of things. The forwarders directive is commented out, as you can see, denoted by the double slash. So we don't need that in the caching only configuration, but we will need that later in the forwarding configuration. The first directive we need is the listen on directive. So we are providing the service on port 53, the standard port for DNS, and we are listening on the loopback interface as well as our physical interface with this IP address. We could have put the keyword any here like this, which means all possible interface. So with this one, we would have the same result. Another important thing to note is that bind is very fussy about the syntax. So don't forget the semicolon after each value and behind the closing bracket as well. The second directive we are gonna put in here is the allow query. So we have to decide which clients we want to provide the name resolution service to. Again, localhost and I put my own subnet here. If we have many clients, we can also specify an ACL to create more complex specifications. And the most important directive we need for the caching configuration is the recursion. So this option enables recursive queries. If the DNS server can't give the answer from its cache, it sends a so-called iterative query to one of the root DNS servers first and gets back a referral, and then it queries the DNS servers responsible for the TLD, and eventually, after this process called recursion, it finds the authoritative name servers for the requested domain and provides an authoritative answer for the clients. So once it finds out the authoritative answer, it stores it in the cache. So subsequent queries for the same domain won't take that much time, since the DNS server won't have to perform this recursive process again. I am going to include two additional uh, directives, and I'm gonna show later how to use them. So the dump file is used to dump the caching information when we issue the rndc dumpdb command, and the statistic file is used to write a statistic to this file when we issue the rndc stats command. That's all we need for now. Let's save and close this file, and let's create this directory, because it does not exist by default, I believe. And assign the appropriate permissions. Before we restart the service, we should check the file for syntax errors with the named checkconf command. And I have made a mistake with the network address, so let me correct it. And check the file again, and nothing is displayed. So we can safely restart the bind daemon. And check if it is running properly. It is, but we can also use the rndc command. So to reload the new configuration file, use the rndc reload, and for the status information, the rndc status. Now let's test the server. We are going to use the Kali host and the dig utility for DNS queries. Since it is not my default DNS server, I use the @ to specify the Raspberry Pi as the server I want to send the DNS queries to. And let's find out the IP address of tryhackme.com, for example. So we have 3 A records, so 3 IPv4 addresses for this domain. And check this row, query time, 500 milliseconds. Not so fast. This is because the recursion process I mentioned before. But this information is now cached. So what if I issue another query for the same domain, 60 milliseconds, and another one, 16 milliseconds. So query time decreased drastically. It provides the answer like instantaneously. See this number in these rows. This is the TTL, or time to leave value in seconds. So the server caches this information for 300 seconds, and if this time passes, the server has to perform the recursive queries again. Let's issue the same DNS request. See, the query time increased again, but we can empty the cache manually with the rndc flush command. And increased query time again. The var bind directory we created previously is empty. Now let's issue the rndc dumpdb and the rndc stats command, and 2 files just have been created. The dump file contains caching information, so I believe it has an entry for tryhackme, which we have queried before. Yes, this row is the name server information, and the named underscore stats file contains statistical informations, number of queries, and a lot of information. And now let's move on to the forward-only configuration. This time, using the forwarders directive, we need to add other DNS servers. And all we do in this configuration is to forward the requests of the clients to DNS servers specified in this section. So we don't do recursion, we don't query the root name servers and other name servers. We are just forwarding request. And I'm gonna uncomment this section and add 2 well-known DNS servers to this configuration. One is Cloudflare's public DNS and Google's public DNS. And we need one more keyword. The most important one to remember is the forward only. With this one, we disable recursion. And it is interesting because it does not conflict with the recursion yes directive. So we could leave it there just as it is right now, but I'm gonna comment this out to not cause any confusion with what we are trying to achieve here. And we are done. Save the file, check for syntax errors, and restart the service. And let's query the server again with the Kali host. So from the client's perspective, it looks the same, but the server configuration is very different between the two modes. The two keywords we should remember is the recursion yes for the caching configuration and the forward only for the forwarding configuration.